For any model in Comsol multiphysics, named selections can be created to be used again and again throughout the simulation workflow. But what if you have several selections already created and want to join them in a way to make even more meaningful selections? You can do this by using Boolean selections. Boolean selections, which include the complement, difference, union, and intersection selections, can be utilized to create a selection as the inverse of one or more selections, a selection of entities that are in one selection but not the other, a selection to combine two or more selections, and a selection of entities that are contained in all input selections, respectively. These selection types, in addition to the adjacent selection type, which creates selections of adjacent geometric entities, have other previously defined selections as input. In this video, we will demonstrate how to create and utilize these selection types. So here we have opened up the shell and tube heat exchanger tutorial model, and you can see we have several explicit selections which we have previously defined in another tutorial. We can use these and any other previously defined selections to help define other selections such as Boolean selections. And please note that Boolean selections are a type of smart selection that automatically updates and accounts for any changes made to the geometry. So if we were to change the imported file, our Boolean selections would still be maintained. We have two domains here. One is the water domain, in which water flows through the tubes. And we have the shell of the heat exchanger, which air flows through. So after creating one explicit selection for the water domain, we could have used a complement selection to create the other. So let's delete the current air domain node. And we'll just move this down. And we'll use a complement selection to select the other domain. There's two ways you can add Boolean selections. You can add through the geometry node by right-clicking and then going under selections, or going into the geometry tab, clicking the selections button and adding it there. So complement selections are used to create selections of the inverse or complement of one or more selections. Since we want to create this for the air domain, we'll rename that. We'll leave the geometry level set to domain. And then we select water domain. With that, we have used the previously defined water domain selection to create a complement selection of the air domain. Let's now create a selection of all of the exterior boundaries of the air domain. We can do this by using an adjacent selection. Adjacent selections are used to select all entities of a given dimension that are adjacent to the entities specified in the input selections. So first, let's rename this air domain exterior boundaries, since that's what we want to create a selection of. We'll leave the geometry level set to domain since we are adding the air domain. And we leave the output entities geometry level set to adjacent boundaries since that's what we want, and leave exterior boundaries selected. Note that the boundaries of the tubes are included in this selection, as they are exterior boundaries in the air domain. Let's also create a selection for the exterior boundaries of the water domain. I'll rename that again. Add the water domain. Leave the geometry level set to adjacent boundaries with exterior boundaries selected. Note that the boundaries of the tubes are included in this selection, as they are also exterior boundaries in the water domain. Now let's create a selection of the baffles in the shell and tube heat exchanger. We can again use an adjacent selection to do this. So first, let's rename this. Select the air domain since the baffles are contained inside the air domain. Leave the setting to adjacent boundaries, and then instead of exterior boundaries, we select interior boundaries. And you can see we have that selection. So you can kind of start to see now how Boolean selections give us a lot of flexibility in terms of creating custom selections for any and all entities in a geometry. We can select parts inside an entity, as well as create a selection of the boundaries, edges, or even points that bound a geometric entity. So let's continue to explore the other types and their functionality. Let's now create a selection for the walls of the water domain, and we can do this by creating a different selection. I'll rename this water domain walls. And you can see how renaming all of these selections really helps when we refer to them later on, such as when we're assigning materials or defining the physics. Instead of referring to these by their default naming convention of explicit 1 or adjacent 1 or 2, we have these selection names reflecting the geometry that they contain. So to create a selection of just the walls of the water domain, we'll change the level to boundary, add the water domain exterior boundaries, and subtract the symmetry, inlet, and outlet selections. And that provides us with the walls. Let's do this also for the air domain. Change the level to boundary, add all of the air domain exterior boundaries, and again, subtract the inlet, outlet, and symmetry selections. Note that the boundaries of the tubes are also included in this selection, as they are exterior boundaries in the air domain, yet the baffles were not selected, as they are interior boundaries in the air domain. Now suppose you wanted to combine selections. You can do so by using a union selection, which we'll do right now. Let's say we want a selection of both the water and air domain walls. We can title this walls, change the level to boundary, and then we can add both of our wall selections. So union selections are used to combine two or more selections into a united single selection. Now let's say we wanted a selection only of the boundaries that are touching both the water and air domain. To do this, we could use a intersection selection. Intersection selections are used to create a selection of entities that are contained in all input selections. So we can change the label to water air walls. Also change the level to boundary. And then for the selections to intersect, we're going to select the air domain walls and the water domain walls. So now we are just provided with the boundaries that come into contact with both air and water in the model. These are basically the tube walls. So now that we've created all these selections and changed the labels, we can easily use them to set up our simulation. Here you can see I just easily chose air domain, and also for the physics. I don't even have to think twice about it. I know what each selection, the parts of the geometry it contains, so I can apply those physics materials and any other conditions or constraints easily. Also, if we were to change the geometry, I'll demonstrate that right here. Here you can see that we have a longer heat exchanger with a different tube and baffle setup. I'll just quickly delete the ignore faces operation since it's not relevant for this new geometry, and delete all these explicit selections that we don't use so we can focus on how the Boolean selections handle changes made in the geometry. All I need to do now is update the first selection we created, which was an explicit selection, since explicit selections do not update if you change the geometry. And then all of my following Boolean selections and their settings are intact. So now you can see how both adjacent and Boolean selections are some really useful selection tools in Comsol multiphysics. They enable us to enter other predefined selections as inputs to the current selection and update if the geometry changes. We went over a few things while defining each of these selection types, such as some advantages of using them in your model, the different types available, and the functionality available depending on the type of selection and the geometry level chosen.